Hello, I'm Mr. Dady, and today we're going to talk about graphing systems of equations. Alright, I'm going to do 3 examples. This is our first one. A system of equations, just two equations in a set that have one answer, or one solution. So there's different methods to do this. You can do it by substitution, elimination, but today we're just going to talk about graphing. Alright. So we have to graph them individually. So I'm going to graph this one first. When you graph a line, it has to be in the format of y equals mx plus b. It has to be. So both of these are good right now to graph. If they're not in that form, you have to switch them. Alright? So for my red one, my y-intercept is going to be 0, 2. And my slope is going to be negative 2. Now since it's negative, I have 2 choices in line for linear equations. Since it's negative, my line is going to look like this. Alright, so I start at my y-intercept, 0, 2. Alright, then I do my slope. The slope is rise over run, so this is actually 2 over 1. Well, negative 2 over 1, but just 2 over 1. So I'm going to rise up 2, and now I need to make sure it's a negative line. So do I go left or right to make sure it looks like that? I go to the left, 1, rise over 1, and then I connect them as straight. All right. Now for our second equation, I'm going to do that in my orange. So my y-intercept is at negative 10. My slope is 4, which is the same thing as 4 over 1. And how's my line going to look, positive or negative? My slope is positive, so my line is going to be positive. So I graph my first point. Right there. And then I do my slope. Rise over run. Rise up 4 over 1. Then I connect the dots. Alright, now, at the beginning I told you it's a system of equations and there's only one answer for both of them. Now we graph both lines, and where it crosses is our solution now to this. So it crosses at 2, negative 2. So that means 2, negative 2, when I plug it in to both of these, it will give me, it'll be the correct answer, or it'll be a solution for it, for both of them. Alright, so let me check it just to make sure. So y equals negative 2x plus 2, and then y equals 4x minus 10. All I'm going to do is plug into 2 for it. Negative 2 equals negative 2 times 2 plus 2. Negative 4 plus 2, negative 2, negative 2 equals negative 2. Correct. So that says negative 2 is a solution for this first one. But for it to be the correct solution for the entire system, it has to be a correct answer for the second one also. And there you go. Negative 2 equals negative 2. It's both a solution, so it is the solution for this system. Alright, now I'm going to do another one. Alright, example number 2. Do the red first. My y-intercept is that back number. I just put a 0 in front of it. 0, negative 4. My slope is right there. It's 1/2. It's already in rise over run form, so I don't need to do anything else. Now I just need to know what the line's going to look like. Since this is positive, am I going to have a negative or a positive line? Positive. And there you go. That's all the information we need for that line. Our second line. Our y-intercept is -1, so 0, -1. Our slope is -1/4. It's already in rise over run form, so we don't have to do anything with it. And since it's negative, it's going to give us a negative line. So now let's graph. Y-intercepts at 0, -4. 1, 2, 3, 4. And rise over run, up 1 over 2. Now it does look like my positive line that I needed. And there you go. That's our line for the railroad. All right, now for our second one. -1, 0, -1 over 4. So I'm going to run down 1 and go over 4. And it's negative, so those connect. Again, it does not matter if you go up or down when you're doing it, just as long as you get the right line out of it, the positive or the negative. Right, so now these two cross at this point right here, which is 4, -2. So that is our answer, is 4, -2. Now if you want to check it, you can plug it into both of them. I'm not going to for the sake of time of the video, but when you plug it in, it does make it. But I'll check it just to make sure. So 4 gives me 2, 2 minus -4 is -2, so that checks out. 4 times that gives me -1, -1, -1, it's -2. And there you go. That is how you graph it. That is the solution. That is the only point between these two lines that make this whole system a solution. Now I'm going to do one more. All right, example number 3. Break down all the pieces. Well, I'm not going to break them down this time. You already know how to do it. So my y-intercept is at -2. And then I have 1/3. So it's rise over run. I know this is going to be a positive line. Rise up 1 over 3. Now, if you remember, at the very beginning, I told you it has to be in this form. This is not in that form. We have to switch this to slope-intercept form by solving for y. Again, if you didn't do literal equations, this might be a new concept for you. But all you have to do, you do the same thing every time. Subtract the x over. And then, if there's a coefficient in front of the y, you divide it. So that gives me y equals -1/6 x plus 1. Now we have to graph that. Don't worry about the fraction. We actually like the fraction there because we have rise over run. So our first point here is at +1 or 0, 1. And then this is our slope, negative. So we're going to have a line that looks like that, because it's a negative slope. So we go up 1, I'll go down. Down 1, 1, 2, 3, 4, 5, 6. All right, and now I can already see where they connect. I'm gonna draw a crooked line. Oops, that's really crooked. There we go. Somewhat better. All right, and that's where they connect. And that point is 6, 0. So that is the answer if you plug it into either of these equations. I would plug it in just to check it if you want. So that would give me 0, yes. That gives me 6, 0, yep. It works out. So we are correct. All right, were 3 examples of graphing systems of linear equations or equations, whatever you want to call them. I hope this helped out. I broke it down pretty thoroughly, and good luck.